Let's talk about restrictions in trigonometric equations. Now, this is also used in trigonometric identities as well, but you will have to work out your trigonometric equation in a sense. So, hence, restrictions in trigonometric equations makes more sense. All right, but you would be asked when you're dealing with trigonometric identities, but then you have to take that identity for that specific restriction and equate it to 0, in which case you'll be dealing with a, a an equation. Now, what exactly you need to know for this is the idea that when you have a restriction for the trigonometric equation, we are simply looking for the value of the variable theta or beta or whatever angle they've given you, can be x, for which the equation or the identity, for example, will be undefined. All right, so if you're given an identity and you're working with an identity, they would want to know for which value of the variable x, theta, alpha, beta, will the identity be undefined. So whenever we have an undefined in mathematics, for example, if we have a fraction such as a over b, I'm just going to use that as an example. You know the restriction should be b cannot equals to 0, because if b equals 0, we have a problem. We're going to run into the denominator being 0, and if the denominator being 0, when you punch a calculator or punching a calculator for that, the calculator is simply going to tell you that math error, all right, something along those lines. But what that essentially is, it means that the number or whatever the fraction won't be defined, the fraction a over b won't be defined for that value 0 on the denominator. All right, so meaning that this function or this fraction in a sense will be undefined. So it happens also that we do have the functions or the identities that are not defined as specific angles. Remember here the value for theta will be a specific angle, so it might not be defined for specific angles. Now we have some few cases in which we have to think of. The first one should be if you're given tangent theta we know is sin theta over cosine theta. All right, so if you're given tangent theta, which is sin theta over cosine theta, you know that the denominator here is cosine theta. Now we have to put a restriction as far as the cosine theta is involved. Now the denominator here is not supposed to be 0. If the cosine theta is some number, the theta is some angle, or for example, that will make the denominator be 0, then this whole thing will then be undefined. And it's just easy to pick up what are the values for theta which will make the denominator equal 0. All we need to do is to take cosine theta and equate it to 0 and simply solve for theta. Now we want to know which angles associated with theta will make this function, for example the tangent theta, equals to 0 in the denominator. All right, so what I'm going to do is to simply take cosine theta and equate it to 0 and simply solve for cosine theta. Remember, here all I need to do is to put, I'm going to rewrite that again so that I can show you, is to just put inverse cosine, and then on the right I'm going to do the same thing, inverse cosine or arcsine 0. And then this and that will cancel theta, and therefore will be cosine second function cosine or arccosine arccosine 0. Now, so if you have the arccosine 0, you will be able to find the angle which is associated with the 0. Remember, the 0 here is some number, as we've talked about in your trigonometric equations. The 0 should be some number which lies between -1 and 1, and can also be equals to a -1 and 1. Now that 0 lies within that interval, and for that reason it means that we will be able to find the angle for that. So you can just simply punch a calculator for that. I'm just going to go ahead and do that. So I'm looking for second function cosine 0, which is going to be 90 degrees. All right, so second function cosine 0 is going to be 90 degrees. All right, so I know that this tangent function, tangent theta, is going to be undefined. Tangent theta is undefined for cosine theta equals 0. All right, so when cosine theta is equals to 0, and exactly that's when theta is equals to plus or minus 90 degrees plus 360 times k, where k is an element of z. Remember, we did this when we were doing trigonometric equations. So this is an equation which basically gives us that this one was going to give us a reference angle, in which case I had the plus or minus the reference angle, which is the 90 degrees, plus 360 being the period of the function, and k is an element of z. So simply that's what you have to do. All right, now let's take another example along the same lines. Let's say we have tangent to theta, and tangent to theta we want to find for which values of x will be tangent to theta, not of x, rather of theta, will tangent to theta, which is a double angle, be undefined. And in that case, we're going to have sine to theta over cosine to theta. Now, specifically, this will work differently compared to the previous one we worked on. All I need to do is just to equate the denominator. Simple as that. Just take the denominator, equate it to 0, solve for theta if they've given you the angle theta, solve for beta if they've given you a beta, and so on and so forth. So I'm going to have cosine to theta is equals to 0. So I'm going to solve for this. All right. Remember, don't expand this into the cos square theta minus sin square theta, or 2 cos square theta minus 1, or 1 minus 2 sin square theta. You don't want to do that. All you are trying to do is to solve for cosine to theta. You're looking for theta, in which case your to theta is going to be second function cosine, or the arc cosine 0. And again, this gave us a 90. This is to theta. Remember, the 90 here is going to be your reference angle. So this tangent to theta will be undefined for, let's say, to theta is equals to 90 degrees, but it's going to be a plus or minus 90 degrees plus 160 degrees. Again, that's my period. All right, times k. K is an element of integers. All right, so you make sure to specifically indicate that and do put that in place. All right, now in this case, I'm going to have to divide both sides by 2 theta. You will recall when we did this by 2 theta, by theta, 2 rather, instead of 2 theta. So I'm going to divide throughout by 2, and then that and they cancel. I'm trying to solve for theta, and then it's going to be a plus or minus 45 degrees. I think 90 divided by 2 is going to be 45 degrees. 45 degrees plus 360, when we divide it by 2, I think it's 180 degrees, I believe, times k. K is an element of integers. So your tangent to theta, that function that's given us, is undefined for cosine to theta equals 0. And that is for theta equals plus or minus 45 degrees plus 180 degrees times k, where k is an element of integers. So we just need to understand that, and then we're done. Let's take some more examples and just sort of wrap our heads around that, and then you will see. Let's say they give you a trigonometric equation and they want you to solve for theta, and after then find the value for theta for which the equation or the trigonometric equation will be undefined. Now, when they say solve for theta, if you have tangent theta, just this will be a little bit of a revision to what we've already covered in trigonometric equations, but we're trying here to specifically deal with an angle of where we're trying to figure out if we are angling, in a sense, where we're trying to figure out for which values of the variable theta will the equation be undefined. All right, so I'm going to multiply that by sin theta is equals to tangent theta. All right, so we're going to go ahead and just basically do the tangent theta, sin theta is equal to tangent theta. We already see we have the denominator cosine theta. Simple as that. Now specifically, you can just solve the equation just like you would any other equation, and I'm going to subtract tangent theta on the left hand side. That's going to be equals to 0. Factor out the tangent theta, and then you're going to have sine theta minus 1, and then that's going to give us a 0. You can see I'm speeding through this because I know it's not a problem for us anymore. So the tangent theta equals 0 and sine theta equals 1. For this one, we're not going to have a denominator, so we're not particularly worried about that. Okay, so if we do not have the denominator, we're not going to have to worry about that. But though you can give the solution for that, for the sine theta equals 1, but I'm not particularly interested in that. What I'm interested in is to find for the value of the variable theta for which this will be undefined. And the tangent is the one that has the sine theta over cosine theta. So the denominator cosine theta. So the tangent theta is going to equal 0. It's going to equal 0. Now the theta is going to be equal to tangent, second function, that's going to be 0. Punching that in a calculator, let's see. So you need to get the solutions first, of course, but that's not the main point of why I'm doing this or why we're looking at this particular type of questions. So that's going to be 0. So theta is going to be 0 degrees plus 180 times k. That's 180 times k where k is an element of integer. So theta is going to be simply 180 degrees. All right, times k. Now here you can also find the sine theta equals 1. We'll have the solution theta equals second function sine. I think also this is 180 if I'm not mistaken, but I'm just going to figure it out. Sine 1, if it's not 90, it's going to be 180. All right, so let's just punch that in the calculator. Shift sine, that's a 1. Okay, so it's a 90. All right, so theta is going to be 90 degrees plus 360 times k, where k is an element of integers. Now after solving the equation, the next question will be then, how do you then find the values for which theta will not be defined. Now, however, the solution on the right won't be the one that you're working with, because here sin theta is not a fraction, so you won't be dealing with this one. So this one should be taken out as being part of the solution. That one will not be applicable in a sense. That's exactly what I'm trying to say. So if it's not going to be applicable for what we're trying to do, you just leave it out. But obviously you will have to give it as a solution, all right? But you won't have to give it as where the function or where the equation, in this case, will be undefined. So the equation will be undefined for tangent theta, all right, only for this one, all right? So if it's undefined for the tangent theta, we know there's going to be sine theta over cosine theta. So with that being said, we know that theta is going to be plus or minus 90 because we've already done that. When we have the cosine theta, it's always going to be the same. So plus or minus 90 and then plus 360 degrees times k, where k is an element of integers. So theta won't be defined for this, all right, or your trigonometric equation in this case won't be defined for this. All right, let's take a last one. Now in this one, they want to know specifically for which values of x is the equation sine squared x over sine 2x equals to tangent x over 2 undefined. Okay, here we're dealing practically with more than one denominator. This one is sine theta over cosine theta. Just make sure. So we already know for which one this will be undefined, but we haven't done this one. So you're going to have to take sine 2x and then equate it to 0 to find for which values of that, since the 2x here is the denominator, the sine 2x here and you can spot is the denominator to that. So we just basically take the denominator. So we have the denominator here and another denominator there, cosine theta. All right, this one is going to be 2x is equals to sine second function 0. I think this is going to give us 180. Let's just go ahead and confirm that. So this is going to be second function sine, and then I'm going to place a 0, and it's a 0. All right, I was wrong. So it's a 0. So 2x is at 0 degrees. All right, so meaning that x is going to be obviously at 0 degrees. The 0 degrees here is my reference angle. It's my reference angle. So if I'm trying to find for that specific general solution, x is going to be 0 degrees, because if I do divide by 2, it's going to be 0 degrees plus 360 times k, where k is an element of an integer. This is when it's 2x anyway. All right, because then I'm going to have to divide by 2. All right, and then k is an element of integers. Now dividing by 2, x therefore will be 0 degrees again, plus 180 times k. All right, now the other one is where you have to take your 180 degrees and subtract the 0, in which case you're going to have the same thing. Now let's take a look at the other one. If you do that, you subtract 180 degrees, 0 from 180 degrees, therefore you're going to have x equals 180 plus 360 times k, where k is an element of integers. All right, and then 180 degrees, obviously if we take 180 degrees and divide by 2, because we're going to have a 2x here, and divide by 2, that's going to be 90. So the x is going to be a 90 degrees plus 180 degrees times k. All right, now taking the other one, we're going to have a similar situation. We already have done this one, the tangent theta, or the tangent x. All right, so for this one is going to be sine x over cosine x. So we're looking for where the cosine x is going to equal 0. X we know is going to be plus or minus 90 degrees, time plus 360 times k, where k is an element of the integers. All right, so but we had x there. We didn't have 2x, unlike the other side where we had the 2x. So for that one, I think it's fine. So I have all my solutions. This one, that one, as well as that one.